All right, so today we have Dr. Kendra Sharp, the Senior Advisor to the Provost for International Affairs at Oregon State. She's also the Richard and Gretchen Evans Professor of Humanitarian Engineering and a Professor of Mechanical Engineering. Her earlier research focused on experimental fluid mechanics, including microfluidics and biological applications thereof. She founded and directs OSU's Humanitarian Engineering program and believes deeply in the value of interdisciplinary education and research and using engineering and technology for positive social impact. Through both her research and humanitarian engineering educational offerings, she collaborates with faculty, students, NGOs, and social entrepreneurs to address global issues in poverty, energy, and water through engineering design and international education. She also has extensive international research and teaching experience in the Netherlands, New Zealand, India, Pakistan, and Thailand, and has received numerous awards and honors from entities ranging from the American Society of Mechanical Engineers to the National Science Foundation. So with that, I want to turn it over to our wonderful guest, Dr. Kendra Sharp. Thank you for joining us.
Sure. Thanks, Ellie. And I'll just make a caveat here. My titles have changed a little bit, but pretty much in the same vein. So thank you so much for the invitation. I'm happy to be here and be able to share a little bit about our humanitarian engineering program at OSU, the type of work that we do, both in research and in engineering education. And I'm actually going to start though by talking a bit about some career paths. And this was something that in my correspondence about this particular seminar series was mentioned, that sometimes the speakers do talk about what types of career paths people take. So I put up here, I was thinking about, and I'll define humanitarian engineering a little bit later, but if you think about really engineering for global development, and you think about what kinds of career paths you might take, I was considering where our graduates have gone. So we have graduates who have gone to work at national labs. One of them is at Idaho National Lab. So he's working in a very technical engineering position, but he spent, after he graduated, wasn't exactly a postdoc, but he was a contractor for the World Bank for several years and was really working on a lot of interesting work, particularly in hydropower and water resources. High Asia had been a specialty of his, and so he was working in that area. And I think that was a really neat way for him to combine his technical expertise with being able to influence policy and directions with the World Bank. He then chose to move into, as I said, a largely technical but managerial type of a role at Idaho National Lab. I have another graduate student who finished a couple of years ago, and she had been in the Peace Corps. So there was a program called the Peace Corps Masters International Program where you come to OSU for a year, do the Peace Corps experience, and then come back, and your master's project was, the subject of your master's project was then something that related to what you'd done in the Peace Corps. I have another student who's finishing in that program. That program doesn't exist anymore because the Peace Corps canceled it, but we did have several people go through that program. And the one who graduated a few years ago, she went and she's been working in relief and disaster assistance technology at Lincoln Labs on the East Coast. So I've had several go into national labs. We've had some other PhD students or master students go into working for non-governmental organizations. So for example, NGOs, and I put up a little logo here for Green Empowerment. That is a Portland-based NGO. They do really great work. They do a lot of work in energy, obviously development, some water. And so he's now, I think, a technical program manager with Green Empowerment. So again, like working with communities all over the world. And Green Empowerment works with, OSU works with Green Empowerment on a couple of different projects. What else? So academics, of course. So we've had some of our master students who graduate have gone into PhD programs, for example, in design science at the University of Michigan. That's a really highly interdisciplinary program. So I had a student who was undergrad, then grad, and then went there. We've had other master students actually go into more policy type PhD programs. Some of our graduate students, when they finished, have really immerse themselves in the social entrepreneurship, for example, working with Burn Design on clean cooking in Kenya. Oh, that was one of our graduates from not too long ago. And then Another option that I'm going to talk about here, I'll talk about a bit more on the next slide because I think it's so timely and fascinating, are some of the federal fellowships, or of course you could look at federal full-time employment. Before I get to that though, I'm just going to point out what I put up here is this Engineering for Change. So this is Engineering for Change is an organization, a professional organization, kind of grew out of the various engineering societies. So American Society for Mechanical Engineers, IEEE, some other types of engineering societies got together, and then they launched this Engineering for Change platform and organization that's, I think it's turned 10 now. And that's a really good place to look if you're interested in this area, interested in engineering for global development in any way, whether you're interested in just looking at the topics, the types of solutions. There are some job postings there as well. And we have, I'm very proud of this, so we've had actually a number of 3 or 4 now graduate students at OSU who have been Engineering for Change Research Fellows. And this is a program where they work on, they do this mostly remotely. They do get together, I think once or twice during their fellowship. And they look at, for example, they build up the solutions library for solutions on clean water. That was one of the ones. And it's given them just a lot of exposure to these different types of, for example, non-governmental organizations and social entrepreneurs around the world. So that's a pretty neat site, and I would definitely point you towards that. And I mentioned here science diplomacy. So I'll go to my next slide here. And so what do we mean by science diplomacy? So this is, the terminology is relatively new, I'm going to say in the last 10 or 15 years. There is a program for science diplomacy through the American Association for the Advancement of Science. You can go look at their program center. But one of the things that the AAAS does is they have these science and technology policy fellowships. And these are fellowships where you do, I think for all of them, you are required to have a PhD. And you can do it either right after your graduation, or you can do it some other time in your career. This is something that I did 20 years ago. So they have programs for congressional science fellows. They have science fellows who work in the US Agency for International Development, or the Department of State, or the National Science Foundation, the Department of Defense, Environmental Protection Agency. So really, this program spans a number of the federal agencies and Congress, and it is an opportunity to go for a year and to work in a year, or actually I think that the diplomacy ones at US Agency for International Development and Department of State are 2 years. And so you have this opportunity to work in a federal agency or on the Hill, and you don't have to have a lot of experience. They're very competitive, they're also very prestigious, and it's a fabulous network. So this is something I was talking about before we started here. I was a Congressional Science Fellow 20 years ago. So in 2001, I was a Congressional Science Fellow, and I worked in the Senate. And I got to work on developing policies around educational programs. So one of the bills that I worked on ended up turning into a program at the National Science Foundation. I also, since 2001 was 9/11, and that happened while I was there, I ended up working on aviation security technology. So we wrote a little piece of legislation that went into some of the post 9/11 legislation around aviation security. And I got to work with, I mean, it felt like there was polarization in the Senate even, and on Capitol Hill even then. I think it's gotten much worse. But at that time, I mean, really the science oftentimes was very bipartisan. So our office worked a lot with Senator McCain's office because he was very big on, he was really addressing climate change and looking at policies that would address climate change even 20 years ago. So we worked on a lot of bipartisan, and we worked with the House and we worked with the other side of the aisle, and were able to maneuver and push policy that way. So I can take a minute and see, I don't know if we want to take any questions now, or if you would like me to just go through. I know I spent more time than I had planned on these, but it's really timely and exciting. And there's a National Science Policy Network that is really focused on, and there's lots of this stuff is on Twitter, and it's focused on more like the graduate student level. And there are these, for example, these like science policy memo competitions, and you can submit to that. There is a journal. It's something where you can get together with other graduate students. I think for PMEC students, that would be a really fantastic opportunity to get together with some of your colleagues and submit something on renewable energy. That would be a really good forum for it. I think that they're having a conference or some kind of virtual meeting coming up around science policy for racial justice that's coming up in really soon. So again, very timely things and kind of exciting. Should I take questions now, or do we want to just go on? Just go on. Okay, I'll go on. Okay, so since I spent more time on that, I may skip through some other ones, but let me just say, let's step back and look broadly at the engineering profession. And I know that some of you are in engineering, others may be in other fields in marine science, but I think it applies to you too. This, there's really a clear need for globally aware professionals. And this was from James Duderstadt, was the former University of Michigan president. And in 2008, he wrote this really landmark report around engineering for a changing world. And this was, I like to look at this quote. I mean, it really talks about how important it is for engineers, because of the changing context, to be able to address this host of global challenges. And to be prepared for that, he posited that we require revolutionary changes in the engineering profession. And I think that then translates to revolutionary changes in engineering education. We have to prepare engineers to be global citizens. And so this is something that we're addressing through our humanitarian engineering program here at OSU. Industry leaders agree that this is true. So this was done, from a survey. These are industry leaders from 2013. And you could see that 84% of them thought that international and global perspectives would be very important for industry 10 years from now. But 90% of them thought that the current ability of engineering education was fair, poor, or very poor in terms of preparing students to work in a globalized world. So if we think, I mean, I like to think big. So I think about the National Academy of Engineering Grand Challenges for Engineering, and I think more, we really address some of the sustainable development goals through our programming here. And you can see there, I mean, the sustainable development goals, so these are goals that are, the target is for 2030. And it's things like zero hunger, or access to energy, or clean water and sanitation. And so I urge you to really, when you look at these, even some of these around whether it's reduced inequalities or life on land, I mean, if you look at different ones of these, you may not immediately see the relationship to STEM, but I'd encourage you to think more deeply about it, that solutions to many of these challenges really do require experts in STEM, including engineering, but engineers can't be operating in isolation. I mean, technical solutions alone are simply not enough. And I think that you'd be really aware of that with the marine energy too. So even if you come up with the best solution, if it doesn't match, you have to think about the economics of it. You have to think about the environmental impacts. There's lots of policies. There's lots of, in fact, human relations on this. Like, you have to think about what do the people who live along the coast think about the technology. So, it's something where you can't be operating in isolation. And this, so this is just from the UN, where they point out too that the science and technology really helps to tackle some of the key sustainable development challenges. Okay, so if we think about some of the statistics, they're really compelling. And this is around poverty. So over 10% of the world's population lived in extreme poverty in 2013. And if you look at clean water, electricity, and improved sanitation, I mean, these are pretty staggering, really. So you talk about like 1 in 3 people does not have access to improved sanitation. So that's a huge issue. And there's a World Toilet Day every year, but the sanitation is really a big issue. So is clean water, and so is access to electricity. Here I'll take a moment to just kind of define what we mean by humanitarian engineering. And this term is sometimes used, it's a little bit nebulous, can be used, engineering for global development is another term that we use. But what I really mean when I'm using this term is the use of science or technology-based solutions to address basic human needs or otherwise improve quality of life for people living in poverty or communities in transition. And we've seen that that students who participate in this program or who are interested in it, we were really looking at training a new type of graduate, so people who have experience solving real world problems in partnership with communities, and that there are multiple pieces of that are important, right? The real world problems is one, but then in partnership with communities is another one. So I like to think of it as we're looking for socially responsive and culturally responsible solutions. And again, like I'd argue that the marine energy really fits squarely into this, that you do have to think about you're responding to needs, I recognize their technology needs for energy, but it's also socially responsive to the needs for energy, for people in certain areas, but then also you have to be culturally responsible as you're implementing them. And then one of the things that we found was that we attracted a broader demographic of engineering students. So I don't need to take time to go through all the details of this, but we have, just to tell you, so we do have a humanitarian engineering minor at OSU. For the minor is really an undergraduate minor. And then we have a number of HEST courses that are taught by faculty across campus. So we have, for example, a course in engineering solutions for global health that's taught out of the chemical, biological, and environmental engineering unit. We have a multidisciplinary perspectives on case studies. So that's actually an eCampus course. We have a field course on household energy in Guatemala. We include anthropology courses in our minor. And then most recently, we have a course that's co-taught actually between an engineering faculty member, Nordica McCarty, and an anthropologist called Innovation for Social Impact. And this is, it will be part of will fulfill our backcore gen ed requirements here once it gets through that process. But so we've got some core courses, and then there's students take thematic electives and are required to take, to do some sort of international or service learning experience. And then, I mean, for example, this is the international field course, and graduate students could participate in this as well. It has been a 4-credit faculty-led study abroad opportunity, and Dr. Nordica McCarty has been working with clean energy and cookstoves for about 20 years, and she has taken students to Antigua, Guatemala, where they build and install cookstoves, they test them, and they conduct impact evaluation with rural households. So these are some pictures from most recently. They stayed in a rural community and did co-design and creative capacity building. So they were really working with community members on design projects, which is I think a really neat cultural experience, as well as an opportunity to think about design in a not such a strictly engineering type of a way. So, and they distributed cookstoves and did cookstove testing and fabrication too. So this course is run in 2016. It's also run in 2018. It was canceled in 2020 due to COVID, but she has been, the homestays and the co-design in the rural community was done in partnership with a small small design firm in Guatemala. And they've been developing and will be offering effectively like a virtual exchange, a virtual collaborative course they'll be offering in the spring this year. Please feel free to contact me if you have questions about that. But one of the things that was really neat about the project that she did, and this was in the first year, I think, is one of the students it was a new graduate student, and one of the students on the program was one of Dr. McCarty's new graduate students, said, we really, everybody measures cookstove use and temperature and efficiency really by proxy. So they're measuring the temperature of the cookstove. So you've got a sensor that's somehow connected to the cookstove, but that's actually a proxy measure. That's not an actual measure of how much fuel is being used. So we really need a more direct measure of how much fuel is being used. And so they developed this fuel usage and emissions logger, and it's got a temperature sensor, it's got a load cell that measures how much fuel is being used and also does some emissions testing, and then it sends the information. It's able to be used remotely and able to send information out even if the observer, the researcher, isn't there. And this is something that's now being used pretty extensively, in fact, with some partners in Haiti and also in East Africa. And it's something where it's actually been really useful during COVID because they have been able to continue doing some of the research even without having people be able to travel. So that was a neat innovation that came out of it. And then Dr. McCarty also has been developing a cookstove usability criteria, and this is a way to look at actually evaluating cookstove usability. And we've had students who work on honors theses. I usually run at least a couple of capstone design teams. Sometimes we do humanitarian engineering themed class projects. So these are things that are outside the actual coursework. Is there some other opportunities as well? I'll take just a few minutes to talk about some graduate research. So I'm going to talk about, this is some research that I worked on with Dr. McCarty. And this was an integrated evaluation of drinking water purification. So this was using both quantitative and qualitative methods to do a laboratory and field assessment of basically a wood-powered water treatment technology. And this is Grace Burleson was a student who was working on this, and she ended up doing, so she had done a capstone project with me, and then she ended up doing a dual degree master's in applied anthropology and mechanical engineering. And you may be familiar with the term user-centered design. This is really, this dual degree was really the embodiment of user-centered design, because if you think about needing to understand the user, that's where we can leverage concepts and the frameworks from anthropology, because this is what anthropologists do, is they study people, right? And they look at how people act and how people behave, and why they behave in certain ways. So this was a chance for her to do, she had a co-advisor in anthropology, and we were looking at this InStove water purification system. So what you have here is you have this green, this is a Cookstove here, the green stove, and then it has an insert, which is a water purifier. So this is really for an institutional size water purification system. And you might ask, oh, I've seen like the Life straw, and what about, you know, a Camelback thing, and why wouldn't you, or a solar bag, you know, why would you use this? And the reason you would use this is because it produces so much in terms of hundreds of liters at a time. So it's really the scale of this and the fact that you can use it with this institutional size cook stove that that's why you would use it. So we tested it at a hostel in Uganda. That's what she was doing. And the concept here is that you have cold water coming in at A. The cold water, it goes into this heat exchanger, and it's actually, so we're recuperating heat from the hot water that's going out. So that helps to improve the efficiency. And then it goes through this heating coil C. You've got a thermostatic valve here, and what that does is it doesn't allow any water through unless it's at 71 degrees C. So pasteurization standards are 71 degrees C for 15 seconds. So if it's 71 degrees C, the water can flow into the kill chamber where it sits for 15 seconds, and then it goes out through the outlet pipe. And it's hot, but since you aren't necessarily looking for hot water coming out, then we're able to bleed off some of that heat and use it to, as I said, improve the efficiency. So a couple things about this concept. We know that largely what people do in rural developing areas for water purification is to boil it. And why do you boil it? Well, you boil it because you can see it. So the boiling is actually, it goes all the way to, of course, 100 degrees C, and you can see it. You can't tell when water's at 71 degrees C, but you can tell when it's boiling. And then you can let it boil for a certain period of time. But that's actually using more energy than you need to in order to have water that you can safely drink, at least according to the WHO standards. So that's where what this is you're using wood. So you put the wood in here, and I'll show a picture of that in a minute. But this helps to really improve the efficiency, so reduce the amount of fuel that is required to pasteurize or create drinkable water. But some of the interesting things that we learned actually during the field tests, so here this kind of shows you what it looks like in terms of the baseline is, okay, we're just going to boil water here on this stove, just, you know, straight wood. And then this is actually in the stove. So she was doing some usability observations. And one of the things that happened was, since you can't see inside of the pasteurizer, and the water that goes in is cold and the water that comes out is cold. And so the question is it really doing anything? How do I know that it's doing something? So that's a reasonable question to ask if you can't see inside. And that was something that, that was something that came up a number of times. And one of the other things that came up was, well, sometimes I want hot water because I just want to make tea or I want to wash dishes. So if it comes out cold, then I have to reheat it so that I can have my tea. So what this ended up, you know, telling us was that, and if I go back a slide, what this ended up telling us was that there was a design modification we could make where you could have a valve here so that you could actually take hot water out if you wanted it. And that A, shows that the water is actually being heated, and B, allows you to just take water off for your tea. But then you could choose whether or not you wanted hot water or if it was going to go through here, and you could pull the extra heat off of it. We worked with some environmental engineering faculty at OSU and graduate students to do some E. coli and virus reduction testing. And that was useful in just being able to quantify how effective the pasteurizer was in terms of in terms of purifying the water. And so what you see here is that the fuel usage required for how much fuel per 1 liter boiling on a traditional fire was 200 grams, where it was only 5.5 grams if you're using the InStove water purifier. Okay, so let's see. I'm at a little over 34 minutes, so I'm just going to talk about a few other things here. Oh, actually, wait a second. I don't seem to have some of my capstone things. I'm not sure how that happened, but I could go get some other slides, because I was going to talk about some of our capstone design projects, or I could just stop here and we could do Q&A. What would you like me to do?
Brenda, do you have some thoughts? Ellie? We have a couple questions in the chat that we could go to.
Okay. Yeah. Why don't we do that?
Let's see. So Bryson Robertson says the Guatemala course content looks amazing. How is it funded? Maybe you've already mentioned that, I think.
No, I haven't exactly. So the way that it's funded, I mean, the trip is a faculty-led study abroad, so faculty-led study abroads they're run through OSU's Office of Global Opportunities, and there is a course fee for it. So it is to some extent student funded. There are some scholarships available. We've been able to award some scholarships also from mechanical engineering for students that helps to defray some of the costs. And the other thing I'll say is that we really work to keep the program costs down. and it's interesting because in this project, so one of the things that I've done a lot of is fundraising, particularly with private donors. And we've had some very generous private donors who've helped support our projects and our students. And what I found is, I've sent students to Uganda, I've sent students to Thailand on these capstone design projects. And I'll send them for a couple of weeks, and it's actually really inexpensive because oftentimes they're staying in a rural setting. Maybe they're staying with a partner. And so we're able to really stretch our money. So we work pretty hard to keep the cost down on that, but it is typically funded by the students. And sometimes we have funds from, as I said, the department, or for example, from my Office of Global Affairs, since we're piloting this virtual exchange, some of the funding will be coming from my Office of Global Affairs. Okay, so in the Cookstove, Bryson, does that help? Yeah.
That's great. That's super helpful. It really just shows that you don't always have to have a major project and a huge award to go and do this stuff. You can find ways to just go after it and do it on a small scale with a student here and a willing partner on the other side. So that was really
cool. Absolutely. And these partners, so I'll just tell you a little bit about the partners. So one of the organizations that I've done a lot of work with is MIT's D-Lab, which is kind of a design for development lab. And it's a pretty well-oiled operation, but I've done a fair bit of work with them. And one of the things that I've done is I've co-instructed or co-led 3 different 2 to 4 week design summits. And so those summits are hands-on design workshops where we go someplace and we bring people in from all over the world, and we work with community members, and we work on design projects and really step through this co-design concept. And so that's where I've met the partners, both for the rural homestays that Nordica has been doing with partners in Guatemala. So that's definitely through that MIT D-Lab network. And it's also, I've been doing several capstone design projects with there's an agricultural entrepreneur, a farmer in Thailand, who's really got this big vision of changing how agriculture is done in Thailand, largely aimed towards moving to organic methods. And we've been developing some sensors for him. I have teams building an agricultural drone for him this term. So that's something too, and that's where one of these design summits was based. So I spent a couple of weeks on his farm in 2017, and we've been doing projects with him since. And it's really neat. And the students go, and they literally, I think they've stayed with the family. So and this is a rural part of Thailand, so there's not much to spend money on, but it's an incredible immersive cultural opportunity. And he's a really visionary person. And I think it's just a great opportunity to see, to have a chance to meet different kinds of people and see how they're really working to, and this is going to sound super trite, but change the world. And so that's a neat opportunity. So yeah, Bryson, we can I'm pretty good at doing things with not a lot of money, and yeah, that's something that I've spent a lot of time doing, is doing things with not a lot of money. So, so you don't have to have the big, huge research grant necessarily. That can help, but it's interesting because I did participate. I was the OSU lead on a project. It was through U.S. Agency for International Development on Partner Center for Advanced Studies in Energy with 2 universities in Pakistan. And the whole project, it was led by Arizona State, and it was like $18 million, something, $18 million. OSU didn't get that, but OSU's piece of it was significant. And it's interesting because what I saw, I was able to look at like, what were we able to do with our, I don't know, like $30,000 to $50,000 worth of funding for our 2-week design workshop that we had in Pakistan, and that was in 2016, versus what we were able to do with literally hundreds of thousands of dollars with this USAID project. And it's interesting because here were these 2 different projects at such different scales, but looking at the impact of them, they both had really significant impact. So that's something I've had a chance to really observe. Okay, and let me ask, I'll look at the next question here. In the Cookstove project, how is the data shared and communicated with the local community? So that's something where, so Nordica has been working with local partners. Local partners are always important to us when we're thinking about doing projects. And in fact, we have an article on a second review right now that is about the ethics of engagement. So engaging with community partners and how we do that in a way that is fair. And so we're actually evaluating our own partnerships based on a framework called the Fair Trade Learning Framework, which was really developed by some of our colleagues on the East Coast. And so with that, it's a question of, well, how are we working with our local partners? And that's where communicating the information back goes through our local partners. And that's something that, again, like we've thought about how we can do that better. Are there breakdowns in that communication? Are there things that we should be communicating differently? Is it necessarily being communicated in their native language? There's some of these questions, and we're constantly thinking about how we can improve the ethics of the university community engagement. Okay, waves to water project seems like it could be extended to look at. Yeah, absolutely. Yeah, and there's so on this Pakistan project, there were a number of students who were really interested in, I think, some of the small scale turbines in rivers to look at clean water and power. So that, I think that is definitely an opportunity.
I had a question. So I was wondering, what are some ways you think that existing engineering disciplines like civil engineering, electrical engineering, mechanical, what are some ways you think that these can incorporate humanitarian aspects and training into their traditional curriculums?
So there are different ways to do this. I'd say, one of the easiest ways. So you can develop something like a minor, right? And you can have dedicated coursework. Students what we've done in developing ours is to try to, so several of the courses account for what's called the baccalaureate core at OSU, which is your gen ed requirements. So that helps. That means that it's not adding time or adding extra courses for students to take. They can use those courses to satisfy the requirements that they would need to satisfy anyway. And it just gives them a way to really fit into their curriculum without extending time to graduation. But there's also, I think there's a real argument for just doing, for example, just starting to put some of these humanitarian engineering themed projects into existing courses, right? You can look at, if you're talking about heat transfer, one of our partners in Uganda her business is really about, well, it's about more efficient growing, but then also more efficient preservation of food. So what they have there is they have all of their food comes ripe kind of in the same season. And so they've got all this food and they aren't necessarily able to preserve it, and they aren't even necessarily able to use it. So some of it goes to waste. And then during another season, you don't have access to all of those fresh fruits and vegetables. So there's an issue of food preservation. Okay, let's look at different types of storage rooms and heat transfer. That's an example of a project that can be put into a very standard heat transfer class. Is you can start looking at, what is some of the efficiencies? What efficiencies would you need? What kinds of materials could you use to and these are, again, like thinking about local materials. So some of the things people do is they use like plastic bags. Maybe they use the plastic bags to create insulation. These are like plastic grocery bags, and they're actually, that's an issue. It's a huge issue in the developing world in terms of waste. They're all over the place if you've seen this. So could you use those, for example, to help improve the insulation? And that's the type of thing that can be put in just in your regular heat transfer class. So, you know, if I had all the time in the world, I would think about going around in my different classes about, okay, well, how do I put these, how can I create projects? You know, we already know that project-based learning is pretty important in engineering education. So how do I create projects in these different courses that that incorporate some of the concepts and then allow you beyond that? And engineering, we have to be accredited, and our accreditation body now does have some standards where you are supposed to be able to look at, or the expectation is that students will be able to put their technical solutions in the context of economic, environmental, and social impacts, for example. So, you know, that fits right along with your accreditation. I know that, let's see if he's still here. Eduardo was on here at one point, Eduardo Cortia Sanchez from Oregon State, there he is. And so he's had a student who's been working on microgrids, and she was working on microgrids in developing world context. So, you know, for example, that's something that he can very readily translate and talk about in the standard coursework.
Yeah, we were thinking about that for the some of the Engineering Plus program, try to convert some of the grad student level. We have a 530, it's Contemporary Energy Applications, is a required course in ECS, but we've had historically some students from mechanical engineering get it, and some other disciplines. Ted teaches this one. I taught it when he was on sabbatical. And I think we're trying to figure out a way to merge my smart grid class with his contemporary energy application class and some energy access on our research on microgrids and essentially energy access, and make a first year energy class that will cover some portion of energy access. And I think our school is calling it engineering for EOP program that comes from VentureWell. I'm trying to figure out what that connection is, but it will check those two requirements for being listed as that class. But from COE will be one of the Engineering Plus courses. We're working on that right now, as of yesterday.
You know, that's awesome. I mean, that's it. So he just told you how we could do it, and it's really, it has to, but it does have to be, you have to have committed faculty who are willing to spend time and energy doing, you know, and their own personal energy to try to incorporate some of these things.
The problem, sorry to just use some more time, but the problem in ECS was that all my power system classes and energy are senior or grad student level. And also our energy class on the grad student side was also a required core course, but also for grad students. So we had the great majority of students don't see a formal power and energy systems class until their fourth year. That was really a difficult path to get from some of them, because it's already kind of late if they want to go do some internships, perhaps on their MECO program, third, fourth year. So it really needs something a little bit earlier if we want to get a long-term project. Even for some of the senior design projects, right, that Kendra, you were mentioning, if they don't have that background, it's very hard to start from scratch.
No, absolutely. Yeah. And actually, I mean, I think, you know, so I talked about the, so there's a couple of things. I mean, we've got the engineering for global development, but then you've also just got, and in my global affairs role, I'm really interested in seeing how at OSU, how students are having access to global learning. And it doesn't necessarily mean that you have to travel. In fact, right now, of course, we're not doing any sort of international travel. So the question is can you still do global learning? And it's, you know, we think about what does global learning mean? And it can be like comparative perspectives, comparative global perspectives. Maybe you're working on research on global challenges. like the research that Dr. McCarty is doing with these sensors, and you can be collecting and analyzing data even when you're not traveling. And arguably that's, around global learning, because you need to understand the context that you're working in. So there are different ways. I mean, another way for global learning is, in fact, literally through some of the like cultural exchange that we have with our international students on campus here. So there's different ways that we can have global learning. But one thing that I'm really, I happen to be kind of personally proud of, because they're both in the thermal fluids systems area within mechanical engineering that I am, is that we've got Dr. McCarty, who's been running this field course in Guatemala, and then Dr. Ryan Franck was supposed to run a course in partnership and collaboration with a colleague in Brazil. And so so this was really interesting. Like his was one of the first faculty-led study abroads that was actually very aimed at the senior, undergraduate, and graduate student technical level. So it was like supercritical heat transfer, but addressing, problems. He was looking at kind of the energy and power context for Brazil, as well as the energy and power context for the US. And that's another opportunity to get comparative global perspectives. Now, unfortunately, the class didn't run because of COVID. So that was disappointing, but he is continuing to work with his colleague in Brazil, and hopefully, sometime in the future. But these are things like, it takes a lot of energy for faculty to develop. I mean, it takes a commitment, and we're under different types of pressures, but it's really nice it's exciting for me. We do have people here at OSU that care about global learning, and that really, that are willing to put some of their own time and energy into developing opportunities like this. And that just makes me really happy. And Eduardo's one of them, so yeah. Oh yeah, okay, so the name of the organization. So Ellie, I may need to look it up when I don't have my presentation up, but I will, what I'll do is I'll get you a link for that, and maybe you can send it out on your listserv afterwards, because it is, I mean, there's this National Science Policy Network. I think it's just called National Science Policy Network. And there's been a lot of emphasis on developing some of that capacity in graduate students. So you don't have to be necessarily a senior faculty member to be doing that. So I'll get that and send it to you. But this engineering for the One World one, Eduardo, is really, that's something that I've been seeing coming up. And VentureWell, some of Nordica's course development for the Innovation for Social Impact has actually come through VentureWell. So she's had some experience with VentureWell. Okay. Other?
Can I make a bit of a comment? We're talking about, the incredible work you've done and Eduardo's done and everyone else has done in terms of leading up these efforts and how they are sort of extracurricular to our core activities. But I think it's also just worth reminding that, if you have an engaged and activated and a student to help you drive that, it really does help it kind of come to the top of our list of things that we have to do.
Absolutely.
So if you have a student who's really keen and wants to do it and has, it might be a family connection, it may be a cousin and an uncle or someone else that helps make that connection. Just to sort of a note to all the students, like, don't wait for the professors to create the opportunity. If you see something or if you're passionate about it, that does sort of get us passionate and be like, oh, let's work on that. I'll push something else lower down the sort of list of things I have to do.
Yeah.
So it's a two-way street. There's a lot of value and opportunities everywhere.
Yeah, I mean, that's a great point. And some of the, for example, things like the Engineering for Change fellowships that our students have done, the research fellowships, that's all, I mean, I might point a student towards that, but then they go and do that. And then they bring that back to us, and then they can contribute in other ways, whether it's around our curriculum or with other students in the lab or our research. So it is absolutely, I mean, as a student, you do have, I mean, so there's the funding question, right? And then there's what else you're doing, but don't hesitate. Like, if you're interested in some of these, like science policy, science memo type of a competition, there are people around that may be willing to review it, for example, or help you with it. And it is somewhat, outside of maybe my core research, but yeah, I mean, having a motivated student who's, really excited about something, that makes me want to work on it.
Yeah.
I have a question. I don't know if you can see. I'm on my phone. My name's Allie. Hi.
Hi, Allie.
In mechanical engineering at OSU. So I was just thinking about we were talking about with the farmer in Thailand and like presumably, I know you kind of said he's really interested in moving toward organic farming. And presumably, although I don't know much about agricultural history in Thailand, traditional farming was organic farming pre, like, you know, the Green Revolution, the spread of agribusiness. And so what I'm wondering is how you make sure that your students sort of have the historical and political and like social background, not just of like what's going on now in Thailand, but like what has led up to this point, for a lot of, just using that as an example, but just generally for these different projects.
No, that's a great question, and that's where so I'll say that that's something that I'd like to do more of, but that just in terms of time, we are often limited on it. For example, with the capstone projects, you know, there's a very defined curriculum that we have to be meeting. So in terms of, you know, some of the context, largely we get that from, so the partner is typically, excuse me, dictating the direction of the project. And so we're getting some of it from the local partner. And that's where, you know, there's nothing, that's where, so for example, on Nordica's field course, she actually has a 1 credit, I'm sorry, the sun, all of a sudden, gosh, look at that, I'm in Oregon and there's so much sun. Okay. So with that, she has a 1 credit background seminar that happens in the spring, and that's exactly what they do, is they go through and they try to, you know, it's a course, this 1 credit seminar that allows people to develop some of the background before they then actually do the field course. And that, I think that's the type of thing, you know, the more we can do that, the better. Sometimes we're limited with the curriculum and we do have to rely on the local partner or the independent background work that students or faculty are doing.
Cool, thanks.
But I really like her model of the 1 credit background before, because I think that that's, I mean, she just felt that you wouldn't have the full context, or you're still not going to have the full context even after 1 credit course, but you're going to have more. Okay, and I do know that we're coming close to time here, so.
Yeah, let's see. Does anyone have any other questions?
I got a question again. This is, does OSU or UW have sort of an Engineers Without Borders sort of clubs and groups that help sort of provide some of these connections for undergrad students?
Yeah, OSU has a quite strong Engineers Without Borders chapter, and that they meet regularly and they have several projects that are going on. I don't know the details of what the status of their current projects because of COVID. I know that they've had, you know, it's changed their travel plans, but they have been doing projects. I know they have one in Cambodia right now. And then I think they've had some other in Central America. The Cambodian one, it's kind of cool. Like we had, so I've got this dual role. I've got the administrative role in global affairs. And we had this group of women entrepreneurs coming through OSU from Cambodia. And so we had a chance to connect, like that was really cool because we had a chance to connect the women entrepreneurs with the Engineers Without Borders chapter that's working in the same country. So it's fun when we have things like that line up. Other questions? I was just going to see, so the National Science Policy Network, excuse me. So this is, and let me put this in the chat here. I think I can just write it to everyone here. So this is on Twitter. This is where I'm familiar with them, or where I kind of see most of their information. So it's the National Science Policy Network. And the way that they describe themselves is it's a consortium of student and trainee science policy and advocacy groups nationwide, focused on sharing resources, networking, and training. And so they have, yeah, November 13th and 14th, they've got this, I'll just put it in here. They've got this, what is it? It's National Science Policy Symposium. That it's virtual. So it's definitely something that you could attend, and it's Science Policy for Racial Justice, intersecting paths towards equity in research, government, and society. So, and I think it's because this is really a network of, tends to be like more junior kind of graduate student type, graduate students or early career people. I don't think that there's, a huge cost to attending it. It might even be free or a pretty low cost.
Well, Kendra, I know this process, and Paul and Ellie will probably say thank you, but at least from PMEC sort of leadership, I just really wanted to say thank you. I think this is unbelievable, and I think it's too often it's unfortunate that too often in our careers we only start to think about these humanitarian sort of angles to our work when we're kind of getting later on, and we've got too many other responsibilities. But I think the closer we can get folks thinking about this early is huge, and particularly in the marine energy space. Indonesia's got huge activity, the Philippines have a huge activity interest in this. There are a lot of developing nations around the world who are going after the Sustainable Development Goals and do see marine energy as an opportunity there. And I think we got some great students who could start to think about that. And I think it also broadens our where you can get funded, where you can do work. Start thinking beyond just classic DOE and start looking at the other agencies that are investigating and thinking about this. And then if you just find a cool opportunity, let everyone know, and we'll try and find some money to make it happen.
Yeah. Sure. I mean, and I do go back to the socially responsible, culturally responsive. So if you're talking about, doing marine energy off the coast of Indonesia, I think, you do need to think about, well, how can I do this in a socially responsible way? And are there conflicts with the culture, or what do I need to know about the culture in terms of where I'm locating them, how I'm communicating with the local communities? Maybe it's even about like how I'm, what's my transmission network set up? Like, is that something that is appropriate for the context?
Yeah, no, without a doubt, is that equitable distribution of the benefits, all that sort of thing needs to be taken into account. So. Yeah. Okay. So that's from me, but I'll leave it to Paul and Ellie to.
Yeah, well, I'll just say thank you as well. It was a fantastic presentation. Learned a lot. I definitely, if you came in late and you were interested in anything Kendra talked about, definitely go back to the beginning when the recording gets posted. She shared a lot of really great ways to get involved or to do this kind of work, other different career paths you could look into. And with that, let's round of virtual applause for our speaker.